Right, question 4 of the term 2 control test. This was the Newton's second law question, which was a bit of an issue because it's grade 11 work. So, they tell you that a crate with a mass of 25 kilograms slides down a plane which is inclined at 15 degrees to the horizontal. During the first part of the motion, from A to B, there is no friction. So from here to here, there's no friction. But part BC has a rough surface. So here I have friction, and we know that friction acts up. First thing they want is a labeled free body diagram of all the forces acting on the crate while it moves from B to C. So when it's here, okay? So we know it's always going to have FG, always going to have the normal force, which is at an angle, and then there's going to be friction, which is acts up. So Fn is the normal force. Alright. Fg is gravity. You could also have told me weight. And F is friction. Okay. Now, you can't put any of the components on the diagram as it stands like this. If you are going to use the components, you have to put both. You have to put the the perpendicular and the horizontal. I'm going to suggest you don't put the components. Put the forces as they're given. Okay? Then they say to you, calculate the magnitude of the acceleration of the crate while it moves from A to B. So from A to B, there's no friction. So if we look at our object again, all that's acting on it is the normal force and gravity. So here's my slope. I'm going to take the normal force out because it's not important. This is 15 degrees. So when I look at it and I put my components in, I've got FG parallel, FG perpendicular. My angle is 15 degrees is in there. So I need FG parallel. Okay? I'm going to need to work out FG parallel because that's the force that's pulling it down. And it's opposite the angle. So this is going to be FG sine theta. Now, F net equals MA. F net, the only force acting on it is FG parallel. FG parallel is FG sine theta, so this is going to be 25 times 9,8 times sine 15 degrees equal to 25A, and A is 2,54 meters per second. Okay, and they said calculate the magnitude of the acceleration, so I didn't need a direction. That was fine. That wasn't a problem. Then they say write down the direction of the acceleration of the crate as it slows down from B to C, right? Only up or down the slope. Most of you got this. As it's slowing down, the acceleration has to be up the slope because otherwise it won't slow down. It's got to be in the opposite direction to the motion. Now, this carries down. So we're trying to lead you in the question. Now they say the magnitude of the net acceleration from B to C is 1,2 meters per second squared. Calculate the coefficient of the frictional force acting on the crate. So, you know, okay, you've just written it, that there's friction going up the crate, going up, but FG parallel is going to be moving it down. Okay, we know that F net equals MA. It's slowing down. So friction is bigger than FG parallel. Okay, if you're going to go that way around. Right? What a lot of you did is, and I'll do the second option in a second, so this equals MA. Okay, and I need you to see something. By going FG minus FF minus FG, I've actually changed my sign convention as well. I'm making up positive, which we really shouldn't do. So we need to change this, because over here, for this question, down is positive. So actually, that's a bad choice. I've got to go FG parallel minus FF equals MA. The issue is friction. Friction is mu K Fn. Okay, friction is mu K Fn. So what that means for us is we need to recognize that Fn is now Fg perpendicular. If I used sine for Fg parallel, I use cos for Fg perpendicular. So this is mu K Fg cos theta. Okay? And of course, Fg is mg cos theta. Why am I doing this? Is because I'm going to try to do this all in one equation because it makes life a little bit easier. Okay? So I'm going to use that over there. Fg parallel is this. Alright, which I actually haven't worked out. So I'm just going to put it in as it is. So 25, 9,8 sine 15 minus mu k 25 times 9,8 times cos 15 equal to 25. Now you need to be careful. I made down positive. You guys are so used to minusing friction that this is where the issue came in. Down was positive. I asked you in the last question, which direction was the acceleration in? The acceleration is up the slope. That means it's in the negative direction. It was minus 1,2. So it was a huge issue. By not putting the minus here, you got completely the wrong answer. So mu k is 0,39. Obviously, you have the option, which is what some people did, to work out friction. So do this in 2 steps rather than, instead of putting that in, is you work out friction and then substitute it into that equation. You'll get exactly the same answer. Except, of course, when you don't put minus 1,12 there. Alright? Here I'm keeping my sign convention. We made down positive right at the beginning of this. Please, please be careful. By minus and friction, down, I made down positive. Acceleration is minus then. Alright, this is where the wheels fell off the bus on this one. Alright. Then, the gravitational force on a probe called Curiosity on the surface of Mars is 3,338. So in other words, Fg on Mars is 3,338 newtons. The radius of Mars, 3,390 kilometers. This was an issue. The mass of the planet is 10th the mass of the Earth, and they want the mass of the probe. This Fg is the force between the planet, Mars, and the probe. Some of you went the way of trying to find the gravitational acceleration on the planet and then finding m. Not a problem. But that you simply could have done this. Now watch. I know that that's 3,308. G is a constant. The mass of the planet was 1/10 the mass of the Earth. The mass of the Earth is a constant, which is given to you on your information sheet. I'm going to divide by 10, and I want the mass of the probe. Most of you got this part. The issue was now the radius. 3,390 times by 1,000 or 10 to the 3. I needed it in meters. When you didn't do that, you got a very ridiculously tiny answer here, which was a problem. This gives me 961,74 kilograms. Some of you thought that the miles pros Mars probe was in grams, was like 900 grams. It was quite ridiculously tiny. So just be careful, please, alright? The big thing is the meters.